In this video, we're going to talk about protocol and what role it has in the network. If you go take a look at the definition of a protocol, it says a protocol is a set of rules. Obviously, the definition doesn't make a lot of sense at a first glance, but let me try to explain you with a real-world example. Let us assume that you wanted to send data from A to B. Now, obviously, as we've discussed, the data will be split up into multiple smaller segments called packets. Let's say they are P1, P2, P3, and P4. Now you can't just send these packets in the network and expect them to reach to the destination. All the network components need to follow a set of rules so that they successfully deliver the packets from source to destination. Those set of rules in computer world, we call them a protocol. All the elements in the network needs to follow this protocol or set of rules to be able to deliver the packets from source to destination. If you were to think network as roads and these packets are like vehicles, then protocol is like the rules that these vehicles need to follow to reach their destination. Without these rules, all these packets are aimless. All the network elements doesn't know where to deliver these packets to. So the protocol that we use to deliver these packets is called an internet protocol. And that's why we have something called an IP address, Internet Protocol Address. An IP address is like a unique identifier of an element in a network so that all the network elements will follow the rules of Internet Protocol to deliver the packets to that IP address, to the element associated with that IP address. Hope it's clear. Now IP address is going to help deliver the packets. It solves the problem of delivering the packets to the destination, but is it reliable? For example, if you send data as P1, P2, P3, P4, by the time it reaches the destination, it may be in a different order. For example, it would be P2, P3, P1, and P4. Obviously, we don't want that. It's very crucial in some scenarios that you retain the order of the packets. So for that, we need to apply additional set of rules, which means we need to introduce a new protocol. And two of the most popular protocols are TCP, stands for Transmission Control Protocol, and UDP, User Datagram Protocol. Depending on the type of communication that you would be requiring, whether it should be reliable or you want more speed, you have to choose either of these protocols. There are many other protocols out there that are used inside the network, but these are the two which are very popular. You can say that TCP is a protocol or set of rules that goes on top of Internet Protocol. So sometimes you might hear terms like TCP over IP or UDP over IP because both these protocols are like sub-protocols which are reliant on the parent protocol called Internet Protocol. Now let us try to understand some of the differences between these two protocols. First, let's talk about TCP. TCP is said to be a connection-oriented protocol, which means when you use TCP, both the parties, sender and receiver, will try to establish some kind of a connection before they communicate or exchange data between themselves. And once they exchange the data, they would say goodbye to each other. The reason why it is important to build the connection is to make sure that the packets are reliably delivered. Let's say node A is going to send packets P1, P2, P3, and P4. And on the receiving end, if one of the packet is missing, the receiving node is going to send a signal to node A that it missed one of the packets. So now the A will send the packet again to make sure all the packets are delivered and along with the information of the sequence of the packets so that B can reconstruct all the packets in a certain order. A good example of why this will be useful is when you try to load a web page. When you send a request to a server from a browser, the URL request, which we'll talk about in coming videos, we're essentially requesting a HTML file. Once you send the request, the server will respond back with HTML data. All the HTML data needs to be rendered in the same order it was sent. So in that case, guess what? We better use TCP protocol. Let us try to understand how the handshake happens. So we have the sender and the receiver. Let's say sender wants to send some data. So it would first send a signal saying it wants to communicate with the receiver. The receiver acknowledges by sending sync acknowledge. That would say, yes, I'm ready to receive your data. And then again sender will send an acknowledgement saying that I've received a signal from you that you have indeed accepted my send request. Once this handshake happens, this is called three-way handshake because there are 3 steps involved. And once this happens, the data will be transmitted or exchanged between these 2 nodes. Once all the data is transferred in the same order they were sent, they both say goodbye to each other. And that's what these steps describe. The sender is going to say, I'm done sending all the data that I wanted to send by sending the signal FIN, stands for finish, and the receiver will acknowledge it along with its way of saying I'm done as well, and sender will again acknowledge it. So that's how communication happens in terms of TCP protocol, and hence it's called a connection-oriented protocol, since there is a connection establishment between sender and the receiver before they exchange the data. On the other hand, if you use user datagram protocol to send the data, say that you wanted to send 4 packets, then it's not guaranteed that all these 4 packets will get delivered. You may see few packets missing. UDP is called connectionless protocol. That means no handshake happens between sender and receiver. So if one packet is lost, it's lost. The sender is not going to send that packet again. Now you might be wondering, when do we want to use user datagram protocol when it is so unreliable? Let's say that you wanted to stream live video. For example, you wanted to stream live FIFA World Cup or live cricket. People from across the world are able to view your streaming on their browsers. Guess what? In this scenario, you would better off use user datagram protocol because there is no additional overhead of ensuring the reliability, and that would save a lot of overhead. In case of live streaming, it's okay to miss some packets here and there. Still, the viewers can view the video without any trouble. So each protocol has its own pros and cons. You have to decide which one fits best for your application. UDP is faster because it does not have to deal with the overhead of ensuring the reliability of the data delivery, and it's reverse for TCP. You'll understand more on protocols in coming videos, especially when we talk about the client-server architecture, etc. See you in my next video.